Hey everyone, thanks for coming on short notice. So there's two things I wanted to talk about today, and I'll start off with the landing of the boost stage. So I'm happy to confirm that we were able to do a soft landing of the Falcon 9 boost stage in the Atlantic, and all the data that we received back shows that it did the soft landing and was in a healthy condition after that. It does look like it was that the stage was subsequently destroyed by wave action, because the seas were very heavy. It was like 15 to 20 foot seas. So we suspect the stage was destroyed due to the essentially stormy seas. But the data is very clear that it shows a soft landing, it shows deployment of all the legs, and that the stage was in a safe state in the water. We also have a video feed, although the link was very weak. So for the video feed, we're trying to clean the video feed up and try to have it be something that where you can make sort of sense of it. And we're going to clean it up as much as we can on the SpaceX side, and then we're going to post it on our website and sort of try to crowdsource, see if people out there can actually make it look even better. Because I know that the people out there are really good at fixing video streams. So I think that's a really huge milestone for SpaceX and certainly for the space industry. No one has ever soft landed a liquid rocket boost stage before. And I think this bodes very well for achieving reusability. As people have maybe heard me say, I think what SpaceX has done thus far is evolutionary, but not revolutionary. And I think if we can make if we can recover the stage intact and relaunch it, the potential is there for a truly revolutionary impact in space transport costs. The cost of propellant is actually only about 0.3% of the cost of the rocket, or of a mission. So a mission costs $60 million. The cost of propellant is only $200,000. So there's the potential there for ultimately a 100-fold improvement in the cost of access to space. So I think with the information that we've learned from this flight, we know we can soft land the rocket. And we're taking some additional steps with the upcoming flight, which will be a commercial mission for Orbcomm to have a much greater probability of getting to the stage in time and recovering it. So we're securing much bigger boats this time. Unfortunately, I think we try to get we call every boat owner on the East Coast above a certain size. And it turns out most of the boats that can take really heavy seas are actually in the Gulf and elsewhere, but apparently not in the greater Florida area. So this time we're going to have much more capable boats, and I think also we kind of got unlucky that we essentially landed the stage in the middle of a big storm, and so hopefully this time we will not have to do that. It will also be splashing down or landing in the water much closer to land than last time. So I think hopefully we'll avoid some of the deep ocean stuff. And then with each successive launch, and we have several more launches this year, we expect to get more and more precise with the landing. And if all goes well, I am optimistic that we'll be able to land the stage back at Cape Canaveral by the end of the year. So that's all great stuff, and I think assuming that happens, we should be able to refly the main boost stage sometime next year. Anyways, it's somewhat of a huge day because we've been trying to do this at SpaceX for a long time, and it's been 12 years, and we sort of finally did it. And now we just got to bring it back home in one piece. So any questions about that? Sure.
Yeah, have you, Jeff House, Space Review, have you identified a landing site at the Cape to bring the stages back to?
Yeah, we've actually worked with Air Force Range Safety to identify several locations at Cape Canaveral where we can land the stage. They've actually been really helpful. So at first we were concerned, well, range safety might be, object to this, but they actually have been really helpful and supportive. And there are several places we can land. It kind of depends on how tightly we can control the landing point. And I think if we can demonstrate tight control, there are actually a lot of places at the Cape that we can land. Mike, sure.
Alan Boyle with NBC News. Elon, was anything sighted or recoverable, or was there just nothing left that you could see when you tried to look for the stage?
So the recovery operations were challenging because we actually couldn't get a boat out there for 2 days. We literally could not find anyone willing to go out there. We even called the Coast Guard, and the Coast Guard wasn't willing to go out. So as soon as we could get out there was, like I said, 2 days later. We actually have been able to find pieces of the interstage. So that the interstage is the carbon fiber structure that joins the first and second stage. And that's certainly something that you would expect to get destroyed by wave action because it's got a big open hole at the top and the waves will come in and kind of blow it apart. So we've recovered most of the interstage. We recovered a portion of one leg, and there were a bunch of other little bits and pieces. We've not recovered anything of the main aluminum lithium airframe.
Hi, it's Frank Mooring with Aviation Week. Does your data show how close you got to your aim point?
Yeah.
And also, how many more attempts will you be able to have to get to that target by the end of the year?
Sure. So in this particular case, we were just trying to get the rocket to go to zero velocity at the water, at sea level, and we weren't trying very hard to get to a precise location. Nonetheless, we were within a few miles of our target, so I think that's pretty good. I think we could certainly tighten it up massively with a little bit of effort.
What kind of CEP, what kind of target do you need? How close do you need to get to have the Air Force let you land there?
Probably we need to be comfortably in less than a 1 mile radius error. But I mean, in principle, we should be able to land with the accuracy of a helicopter. Literally, if you've seen the test flights of the rocket, you can see just how precise it is. I mean, it lands to within less than a meter of its target. So, yeah.
Hi, Dan Leone with Space News. Sort of along the same lines, how much longer is it appropriate or even helpful to continue doing the soft landing tests on the water? At some point, you won't be able to learn exactly what you need to know to do a recovery doing that.
Yeah, we'll only be doing the water landings until we're confident that we can land with accuracy, and then we'll be transitioning to line landing.
Marcia Smith, SpacePolicyOnline.com. How many times do you expect to reuse each of these first stages, and what is your business model for how many launches you need per year in order to make reusability cost effective?
So our pricing right now assumes no reusability. So none of our prices are contingent on that. Any reusability we're able to achieve would only allow us to reduce prices from where they are today. The more often we're able to fly and the more often we're able to reuse the stages and the less work they require between flights, the lower the cost can be. The boost stage is roughly 70% of the cost of a launch. So if we're able to reuse it and refly it with minimal work between flights, and customers are comfortable with that, and it might take a few years for customers to get comfortable with that, then obviously there's as much as ultimately a 70% reduction from where things are today.
Jeff Brumfield with National Public Radio. I know the official line was that this had, I think, slightly less than a 50-50 chance of working. Did you personally think it was going to work on the very first try?
Well, it's not strictly speaking the very first try. The first time we tried to do a soft ocean landing was Falcon 9 Flight 6. So that was about 8 months ago, and that's where we had an issue. Basically, the rocket spun up too much due to the high aerodynamic torque coming in from hypersonic velocity. Something we didn't expect was that even small changes, or even small asymmetries on the outer skin of the rocket would cause it to spin up because it's facing such high forces. So the nitrogen thrusters on board the rocket for that flight weren't able to overcome the aerodynamic torque. For this flight we just had, we doubled the thrust of the nitrogen thrusters. So and also added a bunch more nitrogen coal gas propellant.
Did you think it was going to work?
I gave it sort of a 40-50% chance of working, and so I was that percentage, I think. So I was actually positively surprised by the fact that the legs deployed, landed. It's basically sat there for 8 seconds before we lost data, and that's a better outcome than I'd expected.
Hi, Julia Piper with Environment Energy Publishing. I know there are huge cost savings here. I wonder if you could talk about efficiency or materials savings. Is there any sort of environmental or sustainability benefits coming with reusing these rockets fitting into your larger body of work? I'm thinking Tesla here and the benefits there.
Sure. Well, there's no question. If compared to the way that rocket flight normally works, where the stages all just kind of come back and crash, and there's a bunch of rocket stages at the bottom of the ocean. Reusing the stages is much better for the environment, and it takes much less energy. Then you don't have to keep rebuilding new rockets, and so I think there's certainly a sustainability element there. Yeah.
We have some reporters who are queued up on the phone. If you could give your name and affiliation prior to asking your question.
Thank you, sir. Our first question comes from the line of, I believe it's Mr. Keith King, and he's from CBS News. Please proceed.
Great. Thank you very much. Can you hear me all right?
Sure.
Great. It's Peter King at CBS Radio News. Just a quick yes/no question, and then one that might take a little longer. You know for sure, I just want to make sure I've got it straight, do you know for sure that it soft landed vertically? And the second question is, how long do you anticipate it'll take you to turn around a spent first stage to be ready to fly again?
We know with certainty that it landed vertically with the legs deployed and in essentially a nominal configuration, because we've got the telemetry to show that. So, and there's multiple sources of telemetry. We have sensors on each individual leg. We have multiple inertial sensors and GPS, multiple GPS units on it, and they all sort of agree with that conclusion. In terms of it being ready for reflight, if we were to recover the stage from the ocean, it would probably take a couple months to refurbish it for flight. However, for stage landing back on land near the launch site, in principle, we should be able to refly it the same day. So it's a huge difference, and that's why we're really focused on trying to get it back to the launch site. That's what would really make the huge difference on reusability. And obviously, with the space shuttle, we had a case where there was a partially reusable vehicle, but the space shuttle was neither rapidly nor completely reusable. And in order to achieve a revolutionary improvement in the cost of spaceflight, any reusability has to be both rapid and complete.
Next question from the phone, please.
Thank you, sir. Our next question also happens to be Mr. Bill Harwood from CBS News. Please go ahead, sir.
Yes, thank you. Mr. Musk, how far downrange was the soft landing zone on this flight? And you mentioned a minute ago, taking a little time to get customers comfortable with flying a rocket again that's already been flown. I can agree that might be a real hurdle to face, maybe more than the technical side. Can you talk a little bit about what you'll have to do to demonstrate to them that this is, in fact, a reliable way to fly? Thanks.
Right, absolutely. I think what we'll have to do is do a demonstration reflight without an operational satellite on board. And if that demonstration reflight works, and some customers may want more than one, then that's the thing that would really ultimately convince them. And then I should probably transition to the other sort of news item, which is not as well. Not the first one was positive. This one's a bit negative. The SpaceX has decided to file suit and protest the Air Force ELV block buy. This is a 36-core sole source uncompeted procurement that was signed earlier this year, and that essentially blocks companies like SpaceX from competing for national security launches. Essentially, what we feel is that that this is not right. That the national security launches should be put up for competition, and they should not be awarded on a sole source, uncompeted basis. And it just seems odd that if our vehicle is good enough for NASA and supporting a $100 billion space station, and it's good enough for launching NASA science satellites, for launching complex commercial geostationary satellites, and really every satellite you can imagine. There's no reasonable basis for it not being capable of launching something quite simple like a GPS satellite. So this really doesn't seem right to us. We've tried every avenue to try to figure out why is this the case. Is there anything we can do besides file a protest? And it seems like we're essentially left with the only option, which is to file a protest. The ULA rockets are basically about 4 times more expensive than ours. So this contract is costing the U.S. taxpayers billions of dollars for no reason. And to sort of add salt to the wound, the primary engine used is a Russian main engine made in Russia. And moreover, the person who's sort of heads up Russian space activities is Dmitry Rogozin, who's on the sanctions list. So it seems pretty strange, like, how is it that we're sending hundreds of millions of U.S. taxpayer money at a time when Russia is in the process of invading the Ukraine? And it would be hard to imagine some way that Dmitry Rogozin is not benefiting personally from the dollars that are being sent there. So on the surface of it, it appears that there's good probability of some sanctions violation as well. And we think this deserves to have a spotlight on it. And let's let the sort of sunshine on this. And as I say, sunlight is the best disinfectant. And if everything's fine, then I guess that's great. But that seems unlikely to me.
Questions?
Thank you. Continuing on, we now. Oh, sorry. Please go ahead.
Is this protest happening through JAO? Is that where you're filing at least first? And is it only being filed by SpaceX or any of your other competitors coming on board as well?
It's being filed in the Court of Federal Claims, and there may be others that join, but thus currently it's just SpaceX. And something I want to be real clear about. This is not SpaceX protesting and saying that these launches should be awarded to us. We're just protesting and saying these launches should be competed. And if we compete and lose, that's fine. But why were they not even competed? And it's just that just doesn't make sense. I mean, there's, we've heard statements about, well, there's this like certification process. Like, okay, well, we're most of the way through that certification process. So far, there've been 0 changes to the rocket. This is a paperwork exercise, and since this is a large multi-year contract, why not wait a few months for the certification process to complete and then do the competition? That seems very reasonable to me.
Jonathan Salant over at Bloomberg News. Where are you in the certification process? I know you've had at least one flight approved. Current flight down to the space station, is that another flight you're submitting for approval? And when do you expect to get full Air Force approval to compete?
Well, we've done, technically we've done 9 Falcon 9 flights. Of the exact configuration that the Air Force wants, we've done 4. All 4 of them have completed their mission. That they obviously worked. So, yeah.
Aaron Meadow with Defense News. Have you informed the Air Force of the fact that you're filing this suit, and are you at all concerned that this could damage your relationship with the service?
We did inform the Air Force just before this, before the press conference. And I mean, first of all, I should say, like, it's not as though we're battling the whole Air Force. That's not the case at all. I think we're on very good terms with the vast majority of the Air Force. Our concern really relates to a handful of people in the procurement area of the Air Force.
Hi, Elon. I'm Pat Hose with Defense Daily. It seems one of the frustrations with the company is that the Air Force tells you to do one thing and then you're about to do it, but then they change the rules or perhaps move the goalposts on you. Can you cite some specific examples of how the Air Force has moved the goalposts on you on your quest to become qualified?
Well, I guess the goalposts were certainly moved with respect to for SpaceX relative to when Boeing and Lockheed competed for the ELB contracts. Boeing and Lockheed, that's before they merged their launch business into United Launch Alliance, were awarded a large number of launches, I think maybe 30 or 40 launches under the ELB program before doing a single flight of the Atlas V or the Delta IV. When SpaceX came along and said, hey, we'd like to compete, we were told that we had to have 3 flights of the exact configuration that the Air Force would fly before they would allow us to compete. That seems like, it's a bit like pulling up the drawbridge, after, not quite right. But we did that, we actually did that. And after we did the 3 launches and completed them, that's a month later we were told, the Air Force has done has done this huge sole source procurement uncompeted to Boeing and Lockheed. We're like, but we just did the thing you asked us to do. That seems pretty wrong. Yeah. I should also say this. Normally when there's a sole source, a huge multi-billion-dollar sole source procurement, there's a justification given. In this case, there was no justification provided for this.
Whitney Bright, CBS News Path. Just wanted to change gears a little bit. And if you could talk a little bit about the potential Tesla plant.
Oh, geez. No, I'm sorry. I can't answer Tesla questions.
Okay.
Hi, Dan Leone with Space News again. For the national security business you envision doing, is it going to be mostly Falcon 9? Is it going to be mostly Falcon Heavy? And then on a side note, ULA has a great deal of what SpaceX calls subsidies in the form of support services contracts. Why wouldn't SpaceX, if not requiring the exact same thing, not have similar costs of doing business with the government that would drive up the prices?
Yeah, so it would be, in terms of Falcon 9 and Falcon Heavy, we think probably it's something like 2/3 Falcon 9, 1/3 Falcon Heavy. And in fact, in our protest, we only are protesting launches that we could do. So we're not protesting launches we couldn't do. We're trying to be as fair and reasonable as possible here. And then with respect to the sort of, like, wouldn't our costs just be like their costs? I don't know why their rockets are so expensive. They're insanely expensive. I mean, on the order of $400 million a flight, all things considered. So in our case, our commercial price is $60 million. And we expect roughly a $30 million increase due to Air Force mission assurance requirements. And that seems to be bearing out. So yes, it makes our rocket 50% more expensive, but it doesn't make it 400% more expensive. And I think we have the advantage that our rocket was designed and the factory was built in the 21st century, whereas Atlas V and Delta IV were designed in kind of the 90s, and in fact have a lot of legacy hardware that stretches back to the 70s and 80s, even before if you count the RL-10. So I think the fact that we have a new rocket design with new manufacturing techniques is very helpful for the cost. I think we have a number of design innovations in the rocket that are also helpful for cost. I mean, there's some of it's just like elementary things. Like if you look at the Atlas V, it uses 3 types of propellant. So it uses solid rocket motors, it uses a kerosene first stage and a hydrogen upper stage. Our rocket, our Falcon 9 by comparison, is a 2-stage rocket. That both stages just use rocket propellant grade kerosene. So right off the bat, to the first order approximation, our operational cost and launch are a third of what an Atlas V would be.
Hi, Yang with Bloomberg Television. My question for you is, in announcing this suit, you had your question that you had just posed to the Air Force was, why not wait a few months before awarding ULA the contract? Well, the Air Force awarded ULA the contract a few months ago, back in December, so why are you waiting to file this suit now? And secondly, another question is, I just want to know if you've come any closer to picking a state for the first rocket launch pad.
Oh, okay.
So this is SpaceX related. If you can answer those two. Thanks.
Sure. So we actually only learned about the big sole source award in March. So it may have been signed in December, but it only came to light, interestingly, one day after the Senate hearing on ELB launch costs, which seems remarkably coincidental to me. I don't think that's an accident. So we've really just had about a month of awareness, and we've been sort of somewhat reeling from that news and trying to see, is this real? Is this actually what's going to be the case? And when we basically made no progress with discussions with the Air Force, we felt we had no choice but to file the protest. Oh, launch pad. So, well, and our primary launch location is Florida with Cape Canaveral. So we've got pad 40 on the Cape Canaveral side, and then pad 39A on the NASA side. And we're actually building out 39A with the ability to do the Falcon Heavy. So probably the first Falcon Heavy launch will be out of the 39A pad, which is really an amazing pad with incredible history. It's where Apollo 11 launched from. So I think that's for the foreseeable future, we expect most of our launch activity to go out of the Cape Canaveral, Cape Kennedy area. We're also developing a launch pad on the south coast of Texas near Brownsville, and we're waiting on the final environmental approvals for that. We expect to get those soon, and we'll probably have that site active in a couple of years. And then, of course, we've got our site at Vandenberg Air Force Base in California for polar launches. And as a rough guess, I think we'll have the NASA flights will tend to go out of 39A, Air Force intelligence flights out of Pad 40, commercial GTO flights or geosynchronous flights out of the Brownsville location, and then all polar flights governing commercial out of Vandenberg. That seems like the logical breakdown.
Hi, no, Dana Hughes, ABC News. You mentioned ULA's continued use of Russian engines.
Yes.
Are you arguing why use Russian engines at all?
I do think it's very questionable, particularly in light of international events. Yeah. This seems like the wrong time to send hundreds of millions of dollars to the Kremlin.
Thank you.
All right, thanks everyone. Sure, Alan, what's up?
Are you asking the Air Force to kind of hold up and wait until you're able to get formally certified?
Yeah, I think the right thing to do would be to cancel the oh, sorry. Yeah, I think the reasonable thing to do would be to cancel the 36 core contract, wait a few months for certification to complete, then conduct a full competition. I think that would be in the best interest of the American public, by not by a small margin, but by a huge one.
What would stop other competitors potentially from asking for the same courtesy?
Well, I think they should. Yeah. Yeah. All right.
Thank you.